Simplify using trigonometric identities, more challenging problems 2. In Simplify using trigonometric identities, we simplified these 6 expressions. And in Simplify using trigonometric identities, more challenging problems 1, we simplified these 4 expressions. For these problems in this video lesson, we're going to use the same identities as we did earlier, which are the reciprocal identities, the tangent and cotangent identities, and the Pythagorean identities. And we're also going to use the same algebraic techniques we used earlier, including finding the common factor, using a difference of squares, finding common denominators, and dividing by a fraction by multiplying by its reciprocal. To go to the previous lesson, I invite the viewer to click inside either of the 2 red boxes to get to the videos where the expressions at the right are simplified. The box at the top will get you to the 6 expressions to its right, while clicking the bottom box on the left will get to the 4 expressions to its right. Here's our first expression to simplify. Use the basic identities to change the expression to one involving only sines and cosines, then simplify to a basic trigonometric function. And we have the expression sine x, cosine x, tangent x, secant x, cosecant x. In these exercises, we'll take the advice of our instruction to change everything to sines and cosines, and then to simplify from there. And following the instructions, we notice that sine x and cosine x will not need to be changed or converted. But we'll want to convert these 3 other ratios, the tangent, secant, and cosecant ratios, in order to simplify this expression. The tangent we'll want to convert using the tangent identity, and we'll use the secant and cosecant reciprocal identities to convert these last 2 ratios. And here's the expression with tangent, secant, and cosecant replaced. We can just start canceling ratios. Sine x over sine x cancel to equal 1, and cosine x over cosine x also cancel to equal 1. And what do we have left? Well, we have sine x over cosine x, which using the tangent identity equals the tangent of x, which we box in as our correct answer. Now this one was pretty easy. Who called this problem 1? That was more challenging? Well, I did. Oops. Next problem. Use the basic identities to change the expression to one involving only sines and cosines, then simplify to a basic trigonometric function. And we have the expression quantity secant y minus tangent y times quantity secant y plus tangent y over secant y. Following the instructions, we're going to bring out our tangent identity to convert secant y to sine y over cosine y. And we'll use the secant reciprocal identity to convert the secant of y to 1 over the cosine of y. And here's the expression with all the ratios replaced. We now have quantity 1 over cosine y minus sine y over cosine y times quantity 1 over cosine y plus sine y over cosine y, all over 1 over cosine y. Now we'll rewrite the expression using that common denominator of cosine y and each of the factors in the numerator. We now have quantity 1 minus sine y over cosine y times quantity 1 plus sine y over cosine y, all over 1 over cosine y. Next, we'll multiply these 2 fractions in the numerator together. As a result of this multiplication, we get 1 minus sine squared y over cosine squared y over 1 over cosine y. And we bring the work up to the top, starting the next column of work. And if you question how we came up with this numerator of 1 minus sine squared y, this is how we did it, shown in the lower right using the box method. Sine y and minus sine y cancel each other, so we have 1 minus sine squared y. Now, back to our simplification. How can we divide by a fraction? Answer: dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by 1 over cosine y, we can multiply by cosine y. So now multiplying by its reciprocal, we have quantity 1 minus sine squared y over cosine squared y times cosine y. Cosine y divided by cosine squared y leaves cosine y in the denominator, So we now have 1 minus sine squared y over cosine y. And we can now go to the Pythagorean identity. If we subtract sine squared theta from both sides of this identity, we get cosine squared theta equals 1 minus sine squared theta. So we can replace 1 minus sine squared y with cosine squared y. So we're left with cosine squared y over cosine y, which equals cosine y, which we box in as our correct answer. Next problem, use the basic identities to change the expression to one involving only sines and cosines. Then simplify to a basic trigonometric function, and we have the expression tangent x over cotangent squared x plus tangent x over secant squared x. According to the instructions given, we'll look to turn everything into sine and cosine, and then simplify from there. We'll use the tangent identity to replace tangent x with sine x over cosine x. And these two reciprocal identities using the cosecant and the secant will enable us to get cosecant and secant squared x to be 1 over sine squared x and 1 over cosine squared x respectively. And here's the expression with tangent x, cosecant squared x, and secant squared x replaced. We can divide by these fractions 1 over sine squared x and 1 over cosine squared x by multiplying by their reciprocals. And here's the expression with each fraction changed to division by multiplying by reciprocals. And for each of these terms, sine x over cosine x is a common factor. And here's the expression brought to the top with sine x over cosine x factored out of each term. We should remember that we can use the Pythagorean identity to simplify sine squared x plus cosine squared x. We can replace sine squared x with cosine squared x with 1. So here sine squared x plus cosine squared x is replaced with 1. And in this next step 1 disappears, and we notice that we can use the tangent identity to replace sine x over cosine x with tangent x. So this leaves us with the tangent of x, which we box in as our correct answer. Once in another video lesson I worked out a very similar problem, pretty much using the method just shown. One of my YouTube viewers had another solution that was more efficient, and I want to show it briefly here before going on to the next problem. In this alternative solution, instead of changing the tangent x to sine x over cosine x, we simply factor out the tangent x first. So we have tangent x times quantity 1 over cosecant squared x plus 1 over secant squared x. Next we can replace 1 over cosecant squared x with sine squared x, and also replace 1 over secant squared x with cosine squared x, which, using the Pythagorean identity, simplifies to 1, so we are left with the tangent of x, which we again box in as our correct answer. This alternative solution, when closely examined, is fundamentally the same as the solution at the left, but done more efficiently by factoring out the tangent x from each term, which ends up saving in numbers of steps needed to simplify. And now, our last problem in this video lesson. Use the basic identities to change the expression to one involving only sines and cosines. Then simplify to a basic trigonometric function. And we have secant squared x cosecant x over secant squared x plus cosecant squared x. For this problem, we'll go to our reciprocal identities. Cosecant theta equals 1 over sine theta, and secant theta equals 1 over cosine theta. 1 over sine x will replace cosecant x, and 1 over cosine x will replace secant x. And here it is with the replacements made. We have 1 over cosine squared x times 1 over sine x over 1 over cosine squared x plus 1 over sine squared x. Next we'll get a common denominator in the denominator by multiplying cosine squared x by sine squared x. And with that common denominator and simplifying the numerator, we have 1 over cosine squared x sine x over sine squared x plus cosine squared x over cosine squared x sine squared x. Next, we should notice that sine squared x plus cosine squared x is one side of the Pythagorean identity and can be replaced with the number 1. And here it is with sine squared x plus cosine squared x replaced with 1 and brought up to the top to work down from there. We have 1 over cosine squared x sine x over 1 over cosine squared x sine squared x. Next we can divide by a fraction by multiplying by its reciprocal, so we have 1 over cosine squared x sine x times cosine squared x sine squared x. Now we have cosine squared x over cosine squared x. We see that they cancel to equal 1, and we're left with sine squared x over sine x, which simplifies to sine x, which we box in as our correct answer. In this problem we've used the same techniques we've used all along. I invite the viewer to go to Simplify Using Trigonometric Identities More Challenging Problems 1 for some more problems simplifying using these identities. This has been Simplify Using Trigonometric Identities More Challenging Problems 2. Thanks for viewing.